Hi, we are Alex and Jihae from the Research X Design Lab at KU Leuven. We're excited to present our paper, Engaging Passersby with Rhythm, Applying Feedforward Learning to a Xylophonic Media Architecture Facade, which we co-authored with Maarten, Houben, Yssmin, Bayoumi, and Vande, Moere. So what is media architecture? Media architecture uses technology to enhance public space and encourage interactions with the environment. For instance, In the Air Tonight is a media installation by OCAD University. Blue animations sprawl across the media facade depending on the direction and speed of the wind, and red pulses are triggered by fluctuations in the use of the hashtag homelessness on Twitter. On the right is the Ars Electronica Center. Passersby can send SMS messages to the facade to change its colors, or alternatively jack in their MP3 players on a special terminal to play their music as patterns of movement across the building. In contrast to visual modalities, however, we are interested in how sonic modalities can positively influence the behavior of passersby and create unique and engaging experiences. On the left, the piano stair experiment encourages people to walk instead of taking the escalator by transforming the stairs into a giant playable piano. On the right, Walk Walk Dance is a series of music-making lines populating pedestrian routes across the city, exploring how participation and interaction can create new spaces for play. Our study is focused on the Moere, which translates from Dutch as a mumbling wall person. This 5-year-old xylophonic media architecture facade is situated along an inviting curve, leading from a busy car-dominated beltway into a quiet green park, and results from an intensive co-design process between our research group and an architectural office. When passersby enter the interaction zone, the Moere mumbles out a playful rhythm, which is produced from mechanical solenoids embedded within the facade itself. These solenoids knock onto wooden xylophone blocks, creating a subtle but perceivable sound reminiscent of the materiality of the window frames and natural atmosphere. Although open to integrating technological means in their facade, the architects dismiss the use of lights, displays, or loudspeakers to the respective rustic materiality of the surroundings. And how does the Moere work? A camera overlooks the passageway to detect where the passerby is located. Then, a computer vision software analyzes the video, comparing their locations into 5 predefined zones of the passageway, each of which corresponds to a column of xylophonic windows. However, even though the Moere was able to attract the attention of many passersby in previous years, the building owners were dissatisfied that most passersby did not realize that the rhythm was reacting to them, whereas those who did realize could not understand how they could control the rhythm. This study thus aims to investigate how passersby can be encouraged to engage with the Moere more, 1. Enduringly, by spending more time, and 2. Purposefully, by knowing how to control the rhythm, all without diminishing the unique, subtle qualities of the interactive modality of a xylophonic media facade. And our proposed method approach is through feed-forward learning. The term feed-forward refers to a cognitive affordance that occurs before a passerby acts, in order to teach them what the result of their action will be. In our implementation, the Moere plays a rhythm at a column of windows as feed-forward to invite the participants to follow. When the passerby successfully arrives at the source of the rhythm, they are rewarded with a different, cascading rhythm. After learning, the passerby can compose their own rhythm as feedback to their walking behavior. Within a 2-phase study, we first conducted a controlled comparative study where we recruited 25 participants to engage with a feed-forward-driven and feedback-driven condition. In the feed-forward-driven condition, participants were instructed, in text, to follow the sound suggestion of the facade until eventually it rewarded them with a cascading rhythm. In the feedback-driven condition, participants were instructed to move around to make the facade produce a sound until similarly it rewarded them with a cascading rhythm. In the study, we collected digital logs, response for SUS system usability scale questionnaires, and interviewed data. Regarding results, we analyzed our digital logs on how participants engaged with feed-forward-driven, abbreviated in the figure as FF, and feedback-driven, abbreviated as FB interaction modalities. Compared to the feed-forward-driven condition, participants in the feedback-driven condition spent significantly more time walking, reversing direction, and spreading across more zones in a passageway. We also asked participants to complete a System Usability Scale SUS questionnaire. We did not find any statistical differences in the system usability scores. Lastly, we conducted a brief interview with our participants. To summarize, we found that 15 participants preferred feed-forward-driven because of its understandable goal-reward structure. 10 participants enjoyed feedback more than feed-forward-driven as they perceived themselves to be in control of the rhythm, and 15 participants enjoyed listening to the sound of the rhythms, describing them as interesting, exciting, or melodic. Interestingly, 7 participants liked that the rhythms were spatial, but 10 participants did find the rhythms to be too uniform or monotonous. We identified 3 lessons learned from a controlled study. First, textual instruction can motivate participants to engage. Secondly, because feedforward-driven is more understandable than feedback-driven, albeit less enjoyable, a learning phase using feedforward can inform participants, while a subsequent feedback phase can empower them to improvise. Lastly, using different sets of rhythms with a distinguishable pause between them can avoid repetition and highlight progress. From the insights of our controlled study, we combined the 2 conditions of feedforward-driven and feedback-driven to design how the moeder should engage passerby, and evaluated this in an in-the-wild study. Spanning 30 days during August, we recorded 1,876 engaging instances over this period, and also recorded 21 on-site participants for an interview and questionnaire. Our figure shows how we mapped feedforward and feedback into 3 phases of engagement: passive, active, and discovery, following the PACD model of engagement. In the passive phase, assignment instructions and a repetitive rhythm invites passersby to stop and engage. In the active phase, the passerby learns different rhythms through feedforward-driven and rewarded with a cascade of the whole facade after unlocking 4 sequential rhythms. In the discovery phase, the passersby can improvise freely with the rhythms by moving across the passageway and are rewarded again when they unlock all 4 rhythms of feedback-driven. Regarding results, we hypothesized that the new feedforward engaging strategy helped the moeder to engage passersby more enduringly than the basic feedback strategies of previous years. On the left, the box plots show that the passersby engagement time is indeed significantly longer in the year we conducted our study, 2022, than in previous years. Our second hypothesis was that the duration of reading the textual instruction, as seen in the central box plot, might indicate how long the subsequent engaging instances could eventually last. As seen in the box plot on the left, reading time, engaging instances ending in a passive phase had significantly shorter reading time than those ending in the active phase or discovery phase. Thus, passersby spending more time reading the instruction were indeed more likely to engage towards a higher phase. Our third hypothesis was that the effectiveness of learning at the beginning of feedforward-driven might indicate how far an engaging instance could reach. We tested this by calculating the learning rate, namely the division of completion time between the first and second rhythm and the maximum achieved rhythm of all engaging instances that ended in the active or discovery phase. As seen on the box plot on the right, engaging instances ending in discovery had significantly higher learning rate between rhythm 1 and 2 compared to those ending in the active phase. Thus, passersby who unlocked rhythm 2 faster than rhythm 1 were also more likely to unlock the subsequent sequence of rhythms. We also analyzed the SUS scores with 21 recruited participants, which resulted in an overall score where engagements with the moeder were considered excellent. To evaluate whether the usability of the moeder improved between the comparative and the in-the-wild study, we compared the SUS scores of the 2 deployments and found that participants of the in-the-wild study rated the moeder to have significantly higher SUS scores than those in the comparative study for both feedforward and feedback conditions. Through our interviews, we learned that all participants mentioned that the textual instruction encouraged them to engage, and that all participants agreed that the feedforward learning phase was understandable. In contrast, participants perceived the rhythmic and spatial qualities of the moeder in widely different ways, for instance, describing the timbre of the rhythm as warm, soft, wooden, or cold, harsh, and metallic. However, 19 of our 21 recruited participants did recognize the difference in pitch between the windows, which motivated them to further improvise and create their own rhythms. Participants also had differing opinions on how the rhythm reflected the architectural expression of the facade, saying, "It sounds wooden like the window frame," which contrasts against the saying of another participant, "The sound reminded me of a rainforest, but the building looks very cold and dry." However, all participants agreed that the rhythms brought more value to the built environment as it attracted their attention and motivated them to notice the architecture, as well as facilitating social interactions between each other. As takeaways for our research, we highlight 4 design considerations for media architecture. Our first design consideration is to exploit measuring the duration with which passersby read the accompanying textual instruction to optimize the endurance of the engagement. Our second design consideration is to support newcomers with an initial phase of feedforward to engage passersby more enduringly and purposefully. Our third design consideration is to exploit measuring the learning rate of passersby to optimize the purposefulness of the engagement with media architecture. Our last consideration is to ground the interaction modalities in socio-spatial context of the media architecture in order to optimize the meaningfulness of the engagement. And that sums up our 4 design considerations for media architecture. Thank you for listening.